All right, today we're going to start a new topic which actually should be familiar to you from your business statistics class, BUSN 231, okay? And that would be regression analysis. How many of you remember the words regression analysis from your statistics? How many of you remember what that actually means? What do you do in regression?
Is that where you determine how well the data fits together to the regression?
That's part of it, right? Determining how well your data fits the how well your model fits the data, right? And it's supposed to be a straight line model, right? That's exactly what it is. That's why it's called linear regression. Okay, so in other words, we're trying to predict some variable, and that variable must be continuous based on the other variable values. Okay, so again, we're dealing with supervised learning. Remember, we discussed the difference between supervised and unsupervised, right? In supervised learning, you have a target variable, right? In unsupervised learning, whatever happens, happens. Like clustering, for example, something that we will discuss probably next month. Okay, you just here are the points, and which ones of them are close to each other, right? Whatever comes out of that comes out of that, but you're not targeting any specific column in your data set. Okay, so before we start actually looking at the specific file, let's discuss correlation. Okay, hold on. Yeah, let's discuss correlation. Remember, we looked at visualization at the beginning of the semester, right? And we said that you can. There are different ways how you can represent the data graphically, visualize it, right? So the most popular, probably, ways and the most basic ways how to represent a variable, one variable at a time, would be a bar chart, right? If you have categorical data, or histogram, which is essentially a bar chart but only for numerical data, right? That's one variable at a time. But we also discussed scatterplot, right? Scatterplot is it has two axes, x and y, right? You plot one variable along the horizontal axis x, you plot another one along the vertical axis y, and both variables are continuous. Okay? So, the example that I always use when I teach statistics is car prices. Okay? So let's discuss car prices. So here's what I'm going to do. Alright. Let's say that you are shopping for a car, and that is a used car. Okay, not a brand new, but used car. And let's say that you want a certain specific model. Like, for example, I like Toyota because Toyota seems to be a reliable car, right? I had a good history with Toyotas, right? Toyota is known for its reliability. And you want to buy a Corolla, okay, which is very basic car that pretty much a lot of people can afford, right? And it's reliable. And you want to buy a car which is not too old, all right, so maybe 3, 4, 5, 6 years old, maybe 7 at most. And then you look up the local ads, you go to the local dealers, and they all offer you different prices, right? They have different vehicles, and they are priced differently, okay? In general, what does the price depend on? What do you think are some things that affect how much money the dealer is asking for a used car? The year, right? That means translates into the how old is the car, right? How many years old is the car? So that's one of them. What else? Mileage, right? So how extensively the car was used. What else? Brand. Well, let's say we're talking about this one, right? Yeah, of course. Same car, same year, same mileage, but BMW will be more than Corolla, right? No question about it. Yeah. Brand, make and brand. What else? Features meaning add-ons, yeah, such as, for example, windows rolling down, right? Heated mirrors, right? Leather seats, right? Sunroof, 6-disc CD changer, right? Extra loud exhaust sometimes, right? GPS, built-in rear view camera, this kind of stuff, right? Okay, is the color important or not that much? Can be, right? Cool looking black car versus orange goofy car, right? That kind of thing, right? Which cars, by the way, do you know which cars are statistically stopped most by the cops? Red cars, right? Everybody knows that. Okay. Red cars. Yeah. Okay, so all of these factors, they affect the price. And also, what else, by the way, can affect the price? Let's say I'm buying the car that still has remaining factory warranty. Is it going to be more expensive or less expensive? More expensive, but that's probably correlated with age, right? If the car is old, warranty expires, right? But if the car is not that old, like 3 or 4 years old, maybe it has still leftover warranty. What else? Is number of accidents a factor? It is, right? How can you check the number of accidents? By a lemon check or Carfax, right? So if the accident was severe, it's probably reported, okay? Number of owners can be another factor, right? If the car changed 5 owners, maybe that's a sign of some problem, right? That's why a car changed owners. So there are a lot of different factors that will affect the price of the car. If I would ask you the question, which of these factors do you think is the most influential in terms of it determines the price of the car more than anything else? Which one would you pick? Mileage probably, right? Because it tells you what's the condition of the vehicle, right? How extensively it's used. So mileage is probably the most important. So here's what I'm going to do today. I'm going to take a simplistic viewpoint, okay? I'm going to say that the mileage of the car is the only, or maybe the most important factor. Forget about everything else. So horizontally, X, I'm going to have a mileage, and vertically, Y, I'm going to have a price in terms of dollars, okay? Now, in terms of the dependency, let's say it's a straightforward dependency, right? If the mileage is low, price is low. If the mileage is high, the price is high, correct? Yeah. Mileage low, price is low. Mileage high, price is high. Like this, right? No, it's the other way around, right? Okay, it's the other way around. If the mileage is low, the car is almost brand new, the price is supposed to be high. And if the mileage is high, then the price is supposed to be low, right? So let's say that I set my mind on Toyota Corolla, okay? And I go around local dealers and I look at different cars, okay? And let's say that I'm picking same aged vehicle, okay? 6 or 7 years old, okay? So these vehicles are supposed to be comparable with each other, but in actuality, the mileage can be very different. By the way, I don't know if you noticed, but most of the cars that are sold on the used cars market are what type of vehicles? They're not. They were previously owned by whom? Leasing companies, actually, rental companies. The majority of the cars, like, there is a good chance that if you go buy a used car from a dealer and you check the car history, there is a very good chance that it's a former rental vehicle. Okay. The reason for that probably is, I'm guessing that rental cars, they hold the vehicles in their fleet for 2, 3, 4 maybe years, and they sell them around when the warranty, when the bumper-to-bumper warranty is about to expire. So the vehicle gets 40,000 miles under the belt, that's when they sell them. Okay? Can happen actually pretty quickly, right? It can be a 1 or 2 years old vehicle, which has 45,000 miles on it. What's the average, by the way? What's the average mileage that people normally, like you and me, right? People who use cars mostly to drive to and from work. What is the kind of rule of thumb that insurance companies, for example, are using? 12. Yeah, 12, I believe. It's 1,000 per month. That's considered to be normal under the, if this is a privately owned vehicle, like you own it, right? So 12,000 miles per year, that's considered to be a normal usage of the car. So, but rental companies, of course, they get much higher mileage on them, right? So after 1 year, it's easy. The car will have 30, 40,000 miles on them. Anyhow, so I look at the different cars, and they all have different mileages, but the problem is, these things do not go straightforwardly on the same line like that, okay? I see some cars with low mileage which are priced unreasonably low, something like that, okay? Or some cars with high mileages that are priced unreasonably high, like that, okay? So, in other words, if I collect more information about different cars, this probably is what I'm going to see, okay? So, in general, I can see the trend that's going on, right? The trend will look like that. that if you increase the mileage on the car, the price will, in generally speaking, will go down, right? But it's not exactly a straightforward straight line. Okay, I can't fit all the points on the straight line. So here is what we're going to do. Okay, we're going to build a regression model which is trying to capture that general trend. Now, let me ask you this question, ladies and gentlemen. If I have, let me start a new page. If I have 2 points, kind of talking about overfitting actually, right? That's a good way to illustrate overfitting. That's a picture which actually goes straight from your textbook. Let's say, again, I have mileage and I have price. Okay? If I have only 2 points, this is my car number 1 and here is my car number 2. True or false? If I have 2 points, I will always be able to connect them with a straight line. False? 2 points are always on the same straight line. That is true, right? So therefore, I can always kind of draw a straight line that goes like this, right? And tell me the equation of the straight line, please. Y equals mx plus b, right? Okay, so y equals, so in my case, y is price, right? So therefore, price equals, you know what, let me just write it out. Y equals mx plus b. How do we call m? Slope, and b? Y-intercept. So in my case, it's price equals to m times the mileage, right? Because x is the mileage. Okay, mileage plus b. Okay, so these two numbers, m the slope and b the vertical intercept, are the two unknowns. Okay, all right. Let's say I collected information about yet another vehicle. Okay, I went out and I got the vehicle, which is right here. The mileage was kind of in the middle, but the price was slightly lower than my straight line. Now, can I connect these 3 points with the same straight line, with one straight line? No, right? No matter how I draw the straight line, they're not going to lie on the same straight line, right? But what I can do is I can add, I want to build a model that predicts my data perfectly, right? I want the model that goes exactly through all of my points. I can do that if I start adding more terms into my equation. So look at that. 2 points are on the same straight line and it contains x. Straight line contains x to the power of 1, right? What if I add to my equation a term that contains x squared? So give me a letter. M, B, what else I can use? A, C, yeah, C. C times some number times x squared, right? X squared is the formula of what? Parabola, right? So therefore, I can actually pick up the, oops, hold on. That sucks, right? I can pick up such values of my M, B, and C that my parabola will go exactly through these points, right? Nice. What if I went out and got another point, which is right here, okay? Darn, it's not on the same straight line, but you know what I'm supposed to do in order to make them all fit on the same line, right? So I have to add to the equation what? D times x to the power of 3. Okay? In this case, my line will go like this. Okay? That's going to be my line. And I can keep doing that, okay? So if I have another point, which is right here, say for example, all I have to do really, to have a perfect fit, okay? All I have to do is add another one, f times x to the power of 4. One extra point, you just add x to the extra power, right? And here's what you're going to do. What you're going to get. Something like this, okay? Does it look like a straight line to you? Oh no, right? What if I get 100 cars and the points are all over the place, right? The points are close to the line, far from the line. Then, in order to go exactly through these points, I have to add more and more things, right? And the last one is going to be, I don't know, z times the x to the power of 99, right? And my line is going to look horrible, right? My line is going to look something like this, right? and then it will go to minus infinity and plus infinity on the other end. So I will get an exact equation that captures all of my points. It goes exactly through every single one of my points. Okay? Is that what I want? No, it's going to be a horrible model, right? How do I call this situation? We discussed that before. Overfitting, right? I'm doing too good of a job, okay? It was really simple, straight line that captures what's going on essentially in my data, right? Everything else can be a noise, right? Because some dealers are, greedy, right? Well, not some, all dealers. All dealers are greedy, right? It just depends on how greedy they are, right? Some people will jack up the price and say, yeah, negotiable, okay, $20,000 for this car, but it's negotiable, okay? Some dealers are reasonable, right? Plus, remember, when we started this discussion, we said that, hey, mileage is the only thing that matters, right? Is it? Really? No, there are other things, right? Number of owners, how old is the car, number of accidents, color, extra features. All these things are important. So maybe the reason why my variables, my points were all over the place is because mileage doesn't explain 100%. There are some factors at play at the same time which will account for this variation somewhat. And then, of course, there is always randomness, right? Greedy versus not so greedy, or just simply, that's the price, okay, whatever. So, therefore, I don't want this ugly-looking line, that goes up and down 100 times, right, and then goes to plus and minus infinity. What I want instead of that is that one, okay? So, sure, I'm not going to capture all of my points, but I will capture the effect of mileage on the price, okay? And that's basically what Christmas is all about. Now, let's discuss now, ladies and gentlemen, the idea of correlation, okay? Correlation is a number, right? How statisticians, in general, characterize if two variables are related. In my case, in this example, I clearly can see that mileage is related to price, right? It's inversely related, higher the mileage, lower the price, but still, it's a relationship, right? They are related to each other, okay? So the degree of relationship between the two variables, x and y, is characterized in statistics with the measure called coefficient of correlation. So let's discuss coefficient of correlation. Correlation, okay? You probably remember that from statistics, BUS 231, but that's a reminder, okay? First of all, coefficient of correlation, strictly speaking, statisticians like to use Greek letter rho. Okay, hold on. R-O-H, rho, okay? But I believe that for our intents and purposes, a lot of statisticians are using letter R, okay? So, coefficient of correlation is a number between how much, let's see how much you remember. What's the minimal value and what's the maximum value? Cannot be less than what and cannot be more than what? What's the lowest it can be? -1, right? -1, very good. And what's the highest it can be? +1, right? So it's a number between -1 and +1, okay? Now, ideal situation is when my coefficient of correlation is equal to -1 or +1. In this case, I'm going to say that the relationship between the two variables is perfectly linear. That happens only if my points align perfectly along the straight line. The difference between +1 and -1 is that in one case it's going to be positively sloped, in another case it's going to be negatively sloped. That's all there is to it, okay? Now, here's what I did yesterday. Your jump contains actually, here, no, not this one, hold on. Oh God. Did it not save it? Yeah, it didn't save it. Well, here. Alright. Let's see if that one. Yeah, it's all the same. Alright, your jump program contains a nice tool which we can use in order to kind of illustrate the correlation. Look at that. What I have here is x and y, okay? And coefficient of correlation is computed. Alright? So, right now I have a bunch of points, right? They form circle, two smaller circles, and this smiley face, right? And you can see the correlation coefficient. What is it? Pretty much 0, right? Zero correlation of coefficient of correlation will tell you that x and y are not linearly related. In other words, if x goes up, I can't really say what happens to y. Okay? It does not yield any kind of meaningful correlation, okay, or any kind of meaningful relationship. Now let me show you another example. It's from help. You can do it yourself, okay? If you go to help and go to sample data, and over here we have examples for teaching, I believe, and or is it teaching scripts? Hold on. Where did I find it yesterday? Interactive teaching modules, distribution, or is it teaching demonstration? Demo correlation. Yeah, demo correlation. That's what it is, okay? So, here's what I'm going to do. I will move things around a little bit. So, I'm going to try to move these points so that they align kind of nicely along the same, or maybe along the straight line, okay? Approximately. So, this point I'll move right here. This point I'll move right here. This point here. So I'm just going to make sure that they are not as scattered around as originally. Okay. So do you see what happens with the coefficient of correlation? What is it right now? Can you see that? It says 0.97, right? And my points are not that far away from the straight line, right? It's not a perfect relationship, but it's fairly strong, right? And that's what coefficient of correlation reflects. Okay, it says 0.97. So I can see clearly that x and y are related. X goes up, y goes up, right? Now let me add more points to screw things up a little bit. So I'm going to click outside of this area, okay, to add more points above and below the straight line. Okay? So what do you think about this one? Is it still obvious that x and y are kind of linearly related? X goes up, y goes up? Yeah, but it's less obvious now, right? And coefficient of correlation is 0.93, so it goes down, right? Well, let me add more points. So I'm going to click around like that. Okay. All right. So my cloud of points becomes less and less looking like a straight line, right? So right now I have, oh God, I can see that 7.5, is it? 0.75? Yeah. So let me add more points, okay, all over the place. So now it looks like, it starts to look like a cloud of points, fairly random, right? I can still see this tendency because these pockets right here are empty, right? So in general, x goes up, y goes up, but there is much more variability going on, right? And look at that, my coefficient, correlation coefficient is, oh God, I can't see that, what is it? 0.49, I believe, 0.5. Well, let me screw it up completely, okay? I'm going to click everywhere so that now I have points all over the place, just like that, okay? So, there. Do you see any relationship between x and y? Not anymore, right? And what's the correlation coefficient? Practically zero, right? I could actually start from a different angle. Let's spend 5 minutes of our class. I'm going to rearrange my points now that they have a negative slope, just like that. Okay, so I will move them in a way that x goes up and y goes down. Okay, so now it's also a good relationship actually, right? It doesn't have to be positively sloped, but it's just going to be different. Just like with my cars and prices, right, and mileages. The mileage goes up, the price goes down. So, oops. Okay, this one goes here, this one goes here. Well, that one is kind of out of the line, right? And now let me move 2 more points, this one and this one. Okay. I'd say it's pretty darn good, linear relationship. Not perfect, but close, right? And that is reflected by my coefficient of correlation, okay? It's negative 0.98. Negative basically means that the relationship is inverse, right? X goes up, y goes down, okay? And also, I want to point out that the slope is not important, okay? It can be relatively flat, or it can be relatively steep, or it can go at 45-degree angle. As long as the relationship is there and they align perfectly along the straight line, you will have a perfect +1 or perfect -1. Now let me do the same thing, right? I'm going to add points in order to make things less obvious, less linear, okay? So I'm going to add points here, below the line. I'm going to add points here, above the line. So what do we see? Now it's not 9.8, it's 0.88 with a minus sign, still minus, right? So I'm going to add more points over here and more points over there. And now I'm down to 0.73. So we see what's going on, right? As I create a cloud of points, which kind of obscures my linear relationship, my coefficient of correlation reflects that, okay? So again, it approaches 0, but from a different direction, right? It was going down from 1 to 0, now it's going up from -1 to 0, right? But my point being is, if I completely mess this up, okay, just like that, so that you don't see any straight lines anymore, right? X goes up, what happens to Y? I don't know, all over the place. And that is true for each value of X, right? So my coefficient of correlation, negative 0.02, right? Close to 0. So what does that tell you? That's supposed to tell you that the coefficient of correlation, the closer it is to -1 or +1, the better your model, right? The better your data, actually, not the model, okay? So that means that these two things are almost perfectly correlated with each other. Why do I need that? Well, I need that in order to predict. Remember, we discussed that most of the models that we're going to cover in this class, this semester, are predictive models, right? Means that I have the variables which I'm using to predict a certain target variable. Like, for example, which factors about students affect retention? Who is going to stay at the university and who will drop out of university? Is it GPA? Is it financial aid status? Is it college or your major choice, right? How far are you from school? Is that a factor, yes or no? So I'm trying to predict who will stay and who will go, right? Same thing here. I'm going to try and predict the price of the car based on mileage for now, right? Just mileage and nothing else, okay? Later, on Wednesday, next class, I'm going to add more things. I'm going to say, look, this model is good, or okay model, but can I do better? Yes. If I throw into the model, into the mixture, more factors about the reality. So you realize that what we're doing is we're trying to model the reality, right? Price is the reality, and what affects the price? Mileage, number of accidents, extra features, year, all these things, right? The more you add to the model, the more realistic it becomes, the closer you're able to predict your data, okay? All right, now, let's do this, ladies and gentlemen. Traditional stuff. There is a way that statisticians agreed upon how to characterize whether or not these two variables are strongly correlated with each other or not so strongly. So, therefore, let's do this. For informal assessment, what I'm about to show you is not a rocket science, not exact science, okay? It's kind of, have you seen the Pirates of the Caribbean movie? The first one. The others were crap, right? The first one. Yeah, well, that's true, right? I believe after number 3, I just stopped. I'm like, yeah, I see where it's going. But first one was beautiful, right? Remember when this woman, Elizabeth something, right? She said, I invoke Parley, right? And the old pirate says, well, first of all, you have to be a pirate to invoke Parley, right? Second of all, it's more of the guidelines than the actual rules, right? So, what I'm about to show you is more of the guidelines than the actual rules, okay? So, we're going to call correlation between variables x and y to be strong, okay? Two variables are strongly correlated. Strong correlation. Correlation. If the absolute value of my coefficient of correlation is anywhere between 0.7 and 1, okay? Absolute value is important because it can be negative or it can be positive, right? If I'm positive between 0.7 and 1, or if I'm negative between minus 0.7 and minus 1, then I'm dealing with strongly correlated variables, okay? The closer to plus 1 or minus 1, the better, okay? Then I'm going to call it medium correlation. Medium correlation. If the absolute value of my coefficient of correlation is between 0.3 and 0.7, okay? So if I'm positively correlated at 0.5, for example, or negative 0.5, that's medium correlation, okay? And can you guess which one comes next? Yep. What am I going to call it? We have strong, medium, and weak, right? So variables are weakly correlated. Weak correlation if your absolute value of the coefficient of correlation is between 0 and 0.3. So 0.2, that means that these things are practically not correlated at all. Okay? So that's kind of informal way to think about how strongly the variables are correlated. Okay? Now, ladies and gentlemen, remember, this is what I'm trying to do, right? I have this, by the way, how do we call this type of graph? Starts with S? Scatterplot, right? Scatterplot. Okay, so if this is the scatterplot that I have, then probably if there is a kind of a straight line that I can fit inside the data, that's what I want to figure out from the model, right? So therefore, my goal here is going to be this. You told me that the straight line equation is like this, y equals to mx plus b, right? That's what you told me. Well, let me call things a little bit different, okay? I'm kind of following the tradition. Statisticians have tradition, weird tradition. Okay, so I'm going to write down the equation like that. The price of the vehicle that I'm going to try and predict is going to be based on beta 0, which is y-intercept, okay, plus beta 1 times my x, which is mileage. Okay, and beta 1 I'm going to call what? Starts with S? Slope, right? Starts with S. So it's the same form. I'm just going to use, instead of m and b, beta 1 and beta 0. Okay, so that's my intercept and that's my slope. Okay, that's essentially what I'm going to try to do. And then, of course, because that will give me the equation of the straight line, right? But in actuality, the points are all over the place. So in order to get the points exactly, what I have to do is add noise to that, right? So you get a point on the straight line, but in order to make it real, you have to move it up or down to create this dispersion, this cloud of points, right? So therefore, strictly speaking, this is the model. This is my linear regression that I'm going to try to create, right? This part says it's a straight line, and that part, this epsilon, right, that I'm adding, that's a noise. It says, no, it's not a straight line. There is also points, scattering up and down around the straight line because of two things, right, we discussed. Not everything is predicted by the price, or by the mileage. Mileage is not 100% predictor, right? There are some other factors. Plus, even if I took everything into consideration, there is randomness, always, right? Noise, okay? All right, now, are you ready to rumble? Let's do it, okay? Let's take a look at the data. And the data are posted on Scholar. So go to Scholar, y'all, okay? And right here is the file that I posted recently. It says Toyota Corolla. I think it's an accident that we started to talk about these things now, right? I have a data about 1,000 cars. So download the file Toyota Corolla. Double click on that. It will open up and jump, just like that. Okay, so here is the file. I believe the story behind that file is that the prices are in terms of euros, okay? In Europe, by the way, cars are much more expensive than in the United States. Okay, that's what I was told. For example, Toyota Corolla. How much Toyota Corolla in the United States, brand new? Approximately $15,000, maybe $16,000. Okay, in Europe, it can be 24,000 euros, which is actually even more than $22,000. So, cars in Europe are more expensive. Okay, so these are the prices in euros. Age in terms of months. How old is the car in terms of months? Okay. Do we get any tooltip if we hover over the variables? No, not exactly. Okay. Mileage is in terms of, well, in Europe they don't measure distance in miles. What do they use? Kilometers, right? So mileage, well, it shouldn't be called mileage, right? Kilo mileage or whatever it is, right? Okay, fuel type, diesel or petrol. Petrol is how they call gas, right, in Europe. Okay. Horsepower can be a factor, right? Depends on the size of the engine, right? If you have big engine, 6 cylinders, a lot of horsepower, probably more expensive car, right? Metallic color. That's kind of not exactly what not exactly a continuous variable, right? The car can be metallic color or not metallic color. So we code that as 0 or 1. That's not a continuous variable, that's a categorical variable, right? Automatic car. So 0 means no. If it's not automatic, it's what? Manual shift, right? And 1 means automatic. Again, same thing, right? Not a continuous variable, and you can tell it right here, right? It's a categorical variable. What else do we have? CC, I'm guessing that's cubic centimeters, the volume of the engine, right? Doors, 3 doors, 4 doors, etc., right? Quarterly tax, I don't know if that's important or not, how much money you pay every quarter in terms of taxes, and weight in terms of kilograms, right? How heavy is the car? Okay, so first of all, let's kind of go into the exploration mode, right? Here's what I kind of assumed, that if I do the scatter plot, it will look like that. Let's verify. Maybe I'm barking up the wrong tree, right? And there is no model in the first place. So let's do some data visualization to begin with, right? So let's go to graph, graph builder, and what am I using for my y variable? Vertical. Something that I'm trying to predict, right? What is that? Price. Cool. So I take the price and drag it into the y zone, and then I'm using only one x, right? One predictor, and that would be mileage, right? So I'm dragging it into the x zone. So here is my model. Well, what do you see? Is there a x getting high, y getting low type of dependency? There is, right? So if you start with low mileage, you can see that the prices are mostly in this area, right? 20,000, 25, 30,000 euros, right? But as your mileage gets lower and higher and higher, the bulk of the data starts to go down, and here it concentrates around $10,000, right? But is that a straight line? Or is it more like a curve? More like a curve, right? So if I fit actually the straight line, here's what it's going to look like. That's actually a mental note for me right now, that may not necessarily be the best fit, right? Because really my data shows the curvature, some weird curvature, but what I'm trying to do is this, right? What I'm trying to do is this. Even if the data looks a little curved, I'm still going to try and fit the straight line into that, okay? For now. Maybe it's going to be a bad model. Still has to be discovered, right? Okay, so let's go ahead and do that. We still have, 6 minutes remaining from this class, right? So let's go ahead and build our model, y'all, okay? Very easy. All right, fit model. Here's the shortcut for you, right? Or alternatively, you can go to Analyze menu and fit model. Same thing, okay? So let me use the shortcut. Kaboom. All right, and it looks a little bit different from what we used for classification and regression tree, okay? Y is what? Y is my target variable, right? Which is in this case what? Price. That's my target, right? That's what I'm trying to predict. Everything else goes in this area. Construct model effects, okay? So my independent variables or predictors, or in the regression case, they're also called regressors, okay? Variables that I'm using to predict the target, regressors, okay? They all go in here. But for now, I'm using simplistic approach, right? I'm saying all these things such as age, fuel type, horsepower, number of doors, yada, yada. Not important. Mileage is the only thing that I'm going to use. So I'm going to add that into the model effect, okay? And let me actually point out something for you. Let me go ahead and eliminate the price for now. How do I do that? Yeah, right there. No, let's not do that. Later, when we're going to discuss the logistic regression, not this regression, but logistic regression, I'm going to point that out, okay? So for now, all I have to do is click run, and here's my output, okay? It gives me a bunch of plots, which I'm going to explain a little later, so let's not get into the plots. Let's get into the nitty-gritty, right? And nitty-gritty is this one, right? What I'm looking for is the model, and the model means two numbers, right? One number is beta 0, which is y-intercept. Another number is beta 1, which is slope, right? That's essentially what my model is, okay? So, let's take a look. Parameter estimates. Scroll to the bottom of the output and you will see the section that says parameter estimates, okay? So, here it is. Here's my model. I have an estimate for the intercept which is 15816.8. Let me write that down. So therefore my model is like that right now. In order to predict the price, all I have to do is take 15, oh god, what was that, 8? You have it in front of you. 816? 816.8 plus, hopefully, maybe not. No, right? It's not a plus, it's a minus. Is that a good thing or is it a bad thing? Remember when we looked at the scatter plot, the more mileage you have, the lower the price, right? Is that minus consistent with this? It is, right? Negative slope. So therefore, at least that part I got right as far as the sign goes, right? Minus 0.0631, right? So therefore it's not a minus, it's not a plus, it's a minus. 0.0631 multiplied by the mileage, okay? This is my model, ladies and gentlemen. Okay? Any questions? Make sense? All right. Do we have time to do anything else today? No, we're pretty much out. Okay, so let's end this class right here. And in the next class, we're going to interpret these two numbers. And we're going to... This can be a bad model, or it can be a good model, or it can be an okay model, right? So we're going to kind of discuss how do you differentiate, how do you evaluate how closely your model fits the data. What we had before was a misclassification rate, right? The lower the better. Here we're going to use something else. Okay.